Hey there, I'm so glad you're joining me today. In my 15 plus years of doing this and mentoring developers, if there's one single area that consistently causes the most sweating and anxiety during a deployment, it's absolutely the database. Think about it. We treat our application code with incredible care, right? We review every single line. But when it comes to schema changes, it so often feels like we're just flying blind, manually running scripts and just crossing our fingers hoping for the best. Well, today, we are officially escaping that danger zone. We're going to walk step by step through exactly how to transform your deployment process into a fully automated, rock-solid, production-safe pipeline.
But first, I want you to picture this absolute nightmare scenario. Your team just shipped a brand new feature. The build passes, the deployment goes out, everything looks great. But suddenly, a bad actor finds a single SQL injection vulnerability in your API. And because of how your database connection is set up, that one little vulnerability gives them the power to execute a drop table command. They completely wipe out your production database in an instant. Just poof, gone. Look, this isn't just a scary campfire story to keep developers up at night. It is a harsh operational reality for teams that are stuck in the danger zone of a shared user setup. Think about it. If your application has the power to drop tables, a hacker who compromises your app has that exact same destructive power.
But thankfully, we have a safety net, and it's a tool called Flyway. If you haven't used it, think of Flyway basically as strict version control, but for your database schema. Instead of keeping raw SQL snippets in some shared text document, you're actually storing schema changes as versioned, immutable SQL files right alongside your code. So when the deployment process kicks off, Flyway checks this central source of truth, a specific table it maintains called Flyway Schema History, to see exactly what has already been applied. It automatically scans your migration files, compares them against this history table, and then applies only the new pending migrations in sequential order. And the best part? Once a script is run, it is locked in forever, ensuring everyone on your team and every environment has the exact same schema.
To really understand why this matters, we kind of have to contrast the dangerous default way of doing things with the secure enterprise-grade approach. The most common setup, and what we'll call the absolute bad way, is using one single shared database user for both your application runtime and your database migrations. If your app needs the ability to alter tables during a deployment and it's using that shared user, it essentially retains that massive destructive power 24/7. The good way, on the other hand, is the separated users approach. We are completely dividing the responsibilities here, ensuring that the live running application never holds credentials that are powerful enough to drop or fundamentally alter your database structure.
This is basically the principle of least privilege in action. We are establishing two totally distinct roles. First up, we have the migration user, or the Flyway user. Now, this user is highly elevated. It holds the serious permissions: create, alter, drop, insert, and update. But here is the kicker. Its scope is strictly limited to the deployment window. It's only active while that CI/CD pipeline is actually running. Second, we have our app user. This user is heavily restricted. It only gets the day-to-day runtime permissions it actually needs to function. So just select, insert, update, and delete. The app user absolutely cannot, under any circumstances, change the schema.
So how do we actually wire this up in our code? Well, if you're using Spring Boot, it's actually elegantly simple. You're going to configure two separate data sources right in your application prod.properties file. You map your standard, heavily restricted application runtime user to spring.datasource.username. And then you explicitly map your highly elevated migration user to spring.flyway.user. Notice how we are securely injecting these values using environment variables. You never want to hardcode these. Spring Boot's auto-configuration is incredibly smart here. It picks up those specific Flyway credentials and uses them exclusively for the migration connection, which keeps your application perfectly isolated and safe.
Okay, even with these amazing architectural safeguards in place, as your mentor, I need to be real with you about the operational realities of making database changes. The first one is DDL risk, which stands for Data Definition Language. Remember, Flyway is an automated engine. It's going to execute your migration scripts with zero manual confirmation steps. There are no little safety pop-ups asking, hey, are you absolutely sure you want to do this? If a developer accidentally writes drop table users and that script somehow lands in the migrations folder, Flyway is going to execute it without a second thought. So, the crucial takeaway here is that your ultimate guardrail is actually your team's review process. You have to treat these SQL scripts exactly like critical production code, requiring rigorous peer review before anything ever gets merged.
The second operational reality we face is DML risk, data manipulation language.
So sometimes you aren't changing the structure of the tables, you're changing the actual data inside them. Imagine having to backfill millions of rows of data. Running these massive DML migrations via Flyway can actually lock those tables for an extended period of time, and that causes actual user-facing downtime. To protect against this, you've got to be really strategic. For massive scripts, you either need to batch your writes inside the migration itself or explicitly schedule the deployment to happen during a low-traffic window.
All right, to tie all of the security and strategy together, we need to adapt our deployment pipeline. Let's walk through what a correct 4-step CI/CD workflow looks like. Step 1 is continuous integration. This is where your pipeline builds your single executable artifact, like a jar file. Step 2 is the first part of continuous deployment, actually running the database migration entirely independent of the application. Step 3 is deploying that exact same jar file to your production servers. And finally, Step 4 is the application starting up. Notice how this workflow cleanly separates the act of building your code from the act of altering your production database.
Let's actually zoom in on Step 2 of that workflow for a second. Using a tool like the Flyway Maven plugin, your pipeline is going to run a command like mvn flyway migrate. You'll pass in your specific production JDBC URL and those highly elevated migration user credentials we talked about earlier. Now, why do we do it this way? Because Flyway absolutely must run its migrations directly against the production database before the application is ever allowed to start. We need that schema perfectly updated, verified, and ready to go so that when the new application code boots up, the database perfectly matches what the new code expects.
And that brings us to Step 4, which is a massive, incredibly important shift from how you might be used to working locally. When your application actually boots up in the production environment, it loads its configuration and sees one very specific property. spring.flyway.enabled equals false. This is totally by design. The application skips all of the Flyway initialization logic entirely. It simply connects to the already migrated database using its restricted, heavily scoped runtime credentials. That elevated migration user, it is nowhere to be found in the running application process, completely locking down your attack surface.
As we wrap up this explainer, I want to synthesize everything we've just covered into 3 non-negotiable production safety rules. First, never ever hard-code credentials. Always use environment variables or a secure secrets vault for both your Flyway user and your app user. Second, treat migration scripts exactly like production code. Peer review every single SQL script so you catch a bad alter cable command during a pull request rather than during a frantic post-deployment incident. And third, use environment-specific roles. Your migration user must only be active during that brief deployment pipeline window, ensuring the principle of least privilege is protecting your data around the clock. By internalizing these rules and understanding exactly how to separate your users, you're transforming your database from a hidden liability into a version-controlled, highly secure asset. You are officially out of the danger zone. So take a hard look at your own pipeline today. If your application gets compromised tonight, does the hacker have the keys to drop your database? Don't forget to check the description for the full article and code snippets. If you enjoyed this video, please give it a thumbs up and subscribe. It really helps the channel. Let me know in the comments what topic you want to see next.